More confusing stuff, and this is like a very common support ticket that we get, and that is, why is my disk I/O X and not Y? And when my application is doing Z, and so I see this all the time, and it's the difference between logical and physical I/O. And so to really explain it to people, what I've done is I've broken this up into different categories of examples. So I've got, there can be disk I/O that is unrelated, indirect, inflated, or deflated when compared to application I/O. And here's all the examples you need to give to customers who are trying to get their head around this and debug it and understand why disk I/O is so dramatically different to application I/O. Unrelated. The disk I/O is caused by other applications. It's not the one you're looking at. Other tenants. They're rattling the disks. It's not you. Other kernel tasks. There may be a kernel doing a rebuild of a software RAID volume. And that's just creating disk I/O. It's got nothing to do with any application. That's just what the kernel is doing right now. Indirect. This is application I/O that does not have an immediate corresponding disk I/O, but it might happen later. File system prefetch. I only read 1 megabyte. Why did the disks read 10 megabytes? Oh, that's prefetch. It's warming up the cache. File system buffering. That's where I'm doing writes, but I don't see any disk writes. Then sometime later, there's this big batch of writes. That happens every 5 seconds. It's like, well, that looks nothing like my application write workload, and that's because the file system's buffering. If it's CFS, it's doing its CFS transaction group flushing. Deflated. This is where disk I/O is smaller than application I/O. It can happen because of file system caching. So I'm reading from main memory and not disk. File system write cancellation, where I'm writing to the same blocks before they've been flushed. And so it's like I don't need to, well, you've just trashed it. So I didn't have to do that write that was queued up because you just overwrote those contents. Compression. You may have compression turned on, pretty simple. Coalescing. Multiple sequential I/O can be merged or coalesced before they're read or written to disk. And then in-memory file system. Maybe there's an in-memory file system that doesn't actually ever touch disk. Inflated. In this case, the disk I/O is larger than the application I/O. File system metadata. Why I was getting 40% reads for my write workload. It was in inflation. File system record size. I'm only doing 1 byte reads, but CFS keeps doing 128 kilobyte disk reads. That's because your record size is 128 kilobytes. And that's inflating it by 128,000. Volume manager parity. So you may have a software volume manager like CFS's double parity RAID, and it's doing a read modified write cycle. And so that's causing more disk I/O than you really expect. Phew. So plenty of examples there of why disk I/O can be very different to application I/O. And you can imagine each time a customer asks this question, I'm just confused about ISDAT. I just really want to understand it. It's like, I wish my book was published because I can point you to the pages. Because it takes a while to understand this stuff. There's so many different things that cause it. So at least now I have a reference.